Aloha guys, this is Dr. Tom Walker. We're going to talk about one of my favorite subjects today. And if you can catch the mild sarcasm in my voice, you're smart. Because today we're going to talk about everybody's favorite topic, chemistry. Now, I know what you're thinking. You're saying, Dr. Tom, why studying to be a medical assistant or insurance billing and code or a pharmacy tech or a front office specialist, why do I have to know chemistry? Because all living things function on chemistry. It's vital to life. Just be thankful you're not Dr. Owaya or myself, who had to have a year of general chemistry, a year of organic chemistry, and a year of biochemistry. Okay, so without further ado, let's do it. Chemistry. Of course, I'm taking the PowerPoint the wrong way. Okay, chemistry is basically the study of matter. Matter is defined as anything that occupies space and has weight. There are three states of matter: solid, liquids, and gas. Water is liquid at room temperature. If we heat it on the stove, it turns into gas, steam. And if we put it in the freezer, it freezes, solid. So states of matter depend on temperature. There's also a fourth state, and actually most of the matter in the universe is in the fourth state, which is plasma. Okay, there's a couple different kinds of chemical or of changes that can occur to matter. We can have a physical change, like the picture of chopping wood, or we can set that wood on fire and release thermal energy, which is a chemical change. These are important to understand. Physical change, you just change the physical property of a chemical. You've changed it in a very basic way that cannot be reversed. Okay. The smallest particles that make up our world are called atoms. If a substance only has one kind of atom, like hydrogen or sulfur or copper, etc., those are known as elements. An element is matter composed of only one kind of atom. Trace elements, present tiny amounts, essential for life. Yeah, but they mean it more in a little different sense. But so elements are substances that are composed of only one kind of atom. There are four elements that make up 96% of the human body, or the weight of the human body. They are oxygen, 65%, carbon, 18.5%. Carbon is particularly important for living things. Hydrogen, 9.5%, and nitrogen, 3.2%. So most of our body is composed of just these four, but there are four extremely important elements. Atom, smallest unit of an element, with that element's chemical characteristics. Okay, so I don't remember the exact number. There's about 115 or 16 known elements. Some of them are synthesized by humans. Most of them are naturally occurring. So there's that, however many elements there are, there's that many different kinds of atoms. But there are also subatomic particles that make up the atom, and there's three of those that we're going to learn. Protons, which have a positive charge, electrical charge. Neutrons, which are neutral, that's why they get the name neutron. And electrons, which have a negative electrical charge. A proton has a charge of positive 1, an electron has a charge of a negative 1. This is the solar system model of the atom, the sun, the earth, and planets. For learning purposes, we say that atoms are like this, with the nucleus in the center. The nucleus has the protons and neutrons in it, and the electrons orbiting around the outside of it. Now, that's only a vague description. It's really for learning purposes, but for our purposes particularly, that's good. Okay, so here's a diagram of an atom. The nucleus, and then the electrons are in shells, or orbitals they're also called, around the nucleus of an atom, and they only occur at specific places. Here's an inner shell, here's a second shell, a third. Now, how many shells an atom has depends on how large it is and how many electrons it has. The positioning of these electrons in the electron shells or orbitals is of extreme importance. Okay, here's a drawing of an atom with shows the protons and neutrons in the nucleus and the electrons positioned in these orbitals around the outside of it. They don't really orbit like our example a few moments ago. They're more in a shell. They just exist there. But we don't want to get too deep here. Okay, the atomic number is simply the number of protons in the nucleus. So the atomic number is the number of protons. Hydrogen has one proton. It's the simplest element in the universe, and so it has an atomic number of 1. The atomic mass is the number of protons plus the number of neutrons, so it's the number of particles in the nucleus. I wish we would wait a little bit before getting into this, but let's go ahead and mention it. An isotope are types of the same elements that have differing numbers of neutrons in the nucleus. Like hydrogen has a couple of other isotopes. One of them is called deuterium and another is called tritium. Isotopes vary because they have a differing amount of neutrons in the nucleus. Now, it doesn't say this. It says different atomic mass, which is also true. But I think it's a lot easier for beginning students just to say isotopes vary depending on the number of neutrons in the nucleus. It's still the same element, though. Now, in medicine, we use this some because they're used for diagnostic imaging and advanced medical imaging. Okay, we mentioned how important the electron shells are. Electrons surround the nucleus in orbitals called electron shells. There are in orbits, but they're also called orbitals, probably more common. Now, because this is just the way nature is, because it's the way it evolved, or it's the way the supreme being created it, or however you want to think about it, the first electron shell will hold 2 electrons, and that's all. The second and third shells will hold 8 electrons each. And then as we get larger and larger elements, they have more shells. The number of electrons in the outermost shell, which is also known as the valence shell with a V, valence, is of extreme importance, guys, because it determines how chemically reactive a substance is. So the number of electrons in the outermost shell is of extreme importance. All right, let's take a quick example. Hydrogen, simplest element and most abundant element in the universe. It's what fuels stars and etc. It has 1 electron in its outermost shell, which only has 1 shell. How many does it need to have, does it want to have there? What's the maximum it can have? 2 in the first shell, 2. So hydrogen, because it has only 1 and it wants to have 2, think of it like that, is extremely reactive. So it makes it highly explosive, highly flammable, etc. I don't know when, I don't recall when they use the word valence, but that's real important, valence shell. Now, atoms can bond together in various chemical bonds. And it's the electrical attraction between atoms, and the electrical attraction is out there among the electrons. There's 3 types of chemical bonds: covalent, hydrogen, and ionic. Believe me, we're keeping this as simple as we possibly can. Ionic bonds, guys, are relatively weak bonds. The best example is one they show here. This is table salt. Table salt is made of sodium and chlorine atoms. And they transfer electrons between each other because there's what they want to happen is for these things to achieve the maximum amount of electrons that the valence shell is expected to have or wants to have. The way ionic bonds do this is they transfer one from the sodium to the chloride. That gives the chlorine, a complete complement of 8 electrons. It's satisfied. And that leaves the next shell in the sodium atom as having 8. So that's satisfied. Now, ionic bonds are quite weak, so if you pour sugar or salt into table salt into water and stir it up, it very quickly breaks this bond and becomes sodium ions and chloride ions. An ion is the same element with a different number of electrons. Now remember, an isotope is a different number of neutrons. Ions, which are very important in living things, have a varying amount. So in other words, when you put salt in water and it dissolves and it breaks the ionic bond, you have a sodium ion which has a positive charge of 1, and you have a chloride ion which has a charge of -1. Ions, differing numbers of electrons in the valence shell. Okay, there's another kind of chemical bond called covalent bonds. These are much stronger. And here is a molecule, or I'm sorry, let's back up quickly, as you were, as they say in the Army. When atoms bond together, they form molecules. They form molecules. Where's the word? Right here, a molecule. This is a water molecule. Water is composed of 1 oxygen atom and 2 hydrogen atoms. They share the electrons, and it makes a strong bond. Now, you can take water and run electrical current through it, and it'll separate into oxygen and hydrogen gas. But under normal conditions, it's a very strong bond. Covalent bonds are strong. Ionic bonds are weak. Okay? Sharing, see, like the little picture here with the hand holding, and makes me all warm inside. Okay, there's also another type of bond that forms between water molecules called a hydrogen bond. An intermolecular attraction, not caused by the transfer of electrons or sharing of electrons. It has to do with the water molecule has one end that's slightly negative in its charge, and it has one end that's slightly positive, and opposites attract. This hydrogen bond creates all the familiar characteristics that water has, like surface tension. You know, if we pour a little bit of water out on a table, it forms like bubbles, or it's not just flat. That's the surface tension of water, and it's hydrogen bonding that causes that. Ions are very important. Ions are elements or molecules, in some instances, that have an electrical charge. Hydrogen, for example, in its normal state is electrically neutral. It has a negative charge in its 1 electron and a positive charge in its 1 proton, and that cancels each other out, and so it's neutral. It doesn't have an overall electric charge. If you remove the single electron that hydrogen has, then it just has the 1 positive charge in the nucleus of the proton, and so it then obtains a charge of +1. Let's see what they say. Atoms are groups of atoms, molecules, that carry an electrical charge. There's 2 kinds. Positively charged ions are called cations. Negatively charged ions are called anions. How do I remember this? I just think of cats as being positive, and they're nice and soft and furry, and we like to hold and pet them. They're positive. So a cation has a positive charge. When you take ions and dissolve them in water, like sugar or salt and things, these dissolved ions are called electrolytes. Electrolytes, as we will soon learn, are vital for life. Absolutely vital. Without them, our nerves don't work. Okay, common cations. Sodium. Now, briefly, many of these substances, guys, have been known since ancient times, so they had Latin names. So the chemical formula name for sodium, or abbreviation, is Na. That's based on the Latin name. Same with iron, Fe. Calcium, Ca, is more regular, so it has 1 that makes sense. Calcium forms an ion of 2 positive charges, as does iron. Sodium forms one with 1. We're moving along. We're going to run out of time shortly, so here's common cations. Ones with a positive. Remember, cats are positive. Hydrogen, extremely important in acid-base balance and pH. Potassium, again, known in ancient times, so it's the Latin word, forms a positive ion. Okay, guys, we're going to have to cut it short. See you next time. Dr. Thomas signing off. We'll continue on the next